Okay, I actually wanted to go over the TruSEQ library prep workbook with you guys, just to clarify anything that may be confusing in regards to this worksheet. So over here, one of the important things is a number of columns. We're doing things column-based now. Right now, I'm using one column, so it shows 8 samples. If I were to change this value to 2, it will change this to 16, and as previous calculators have worked, it has changed the values within the depot block as well as the PCR plate. In this example, I'm actually going to be using one column instead, and that should change my values here. As you see, we have the N repair mix, resuspension buffer, ampere beads, and PCR master mix. With the N repair mix, that actually is a little bit different than it was previously. We're actually mixing resuspension buffer, as you see in this area right over here, and they're color coded. So we're going to be mixing 360 microliters of N repair mix with 360 microliters of resuspension buffer. We're actually dividing this into 4 wells, and so you're going to divide this 720 into 4 separate wells. So it's 180 microliters each. And the same with the PCR mix. We're adding 266.7 microliters of the PCR master mix, and in combination with the PCR primer mix, which is 53 microliters, and we divide that amongst 4 wells. Previously, they had their own columns, or I should say they would be added in separate additions as the method progressed, but this actually makes it much more efficient and it's faster. Next thing I'd like to scroll down to show you guys is the indexing thing. There may be a little bit of confusion with this. And just like with the depot block right in this area, for the A-tailing mix, we also have a little cocktail or a mixture that we make, and that shows the A-tail mix over here of 133 microliters, and we're mixing it with 26.7 to make 160, and that's actually being divided here. So we're adding 20 microliters of this cocktail that we just made into column 1. Now, the stop ligase buffer actually you can add to this particular column. We're doing 4 wells here, so this is 15 microliters, and again, this is based off of 8 samples, or I should say 1 column. Previously, we had, I believe, the ligation mix in 2, but we're not doing that anymore. We're actually combining the ligation mix with the index oligos and resuspension buffer, and dividing that, on the plate. If you look over here on the right side of this Excel sheet, this is the you'll see the mixture over here. Say, for example, index 1. We have ligase mix, we have resuspension buffer, and index oligo. We're adding 6.7 microliters of each of these reagents, and that should total 20.1 microliters. On this actual map over here for this PCR plate, it shows in column 4 and 5 we have our index like it was previously. This is index 1, this is index 2, this is 3, and so forth. So for index 1, we're going to be dispensing 20 microliters of that cocktail that we added to the well for index 1. And if you notice, for index number 3, we're also dispensing 20 microliters in here. Alright, so it's important that we make this mixture here and add that to the plate and not just index to this row. Now for the indexing section, this is an area where you can actually modify the names. I know right now by default we call this index ID 001, but if we wanted to custom name this, or whatever the customer wants to use for naming conventions, if we wanted to call this, I'm going to make a different name, just say barcode 1. You're going to notice on the left side of the Excel sheet over here, that'll change. So if I click enter, you're going to notice instead of it saying ID 001, it's going to say barcode 1, and that'll give it a unique identifier. But the program should know to go to the correct position for index 1. I'm actually going to change this back just so we're consistent. So for each one of these, on the left side, this is going to show where you place your index for for the designated sample that it should go to. So, for example, for the box that I had, it has index oligos 1, 3, 8, 9, 10, and 11. I assigned those to these wells. Since there were only 6 in that kit, I had reused 2 of these. And if you notice, index oligo 1 is used twice, as well as 3. So in the sample count, it will actually show index 1 is used for 2 samples, as well as 3. But for the rest of these, for 8, 9, 10, and 11, it will show 1 sample. Now it's important to do this after you're completed adding the index information. You need to click to save index information. That's important. If you don't do this, the program will not work properly when it actually goes to do the indexing step. One extra thing I did want to note that I did upload to the FTP the index workbook that was used previously. There's actually an update because for that particular workbook, because I had to add an extra macro in there, which I want to show you next. So in here, within the actual indexing protocol for the library prep, DNA library prep, TruSEQ, I need you to open up the TruSEQ indexing side, and right at the very start, where it says Open Workbook for the indexing XLS, I need you to add one more macro, and that's over here, the line right after it. It's called Get Index Information. All right, so this is a new macro that needs to get called, and what this macro does is it gets that information that was saved previously by clicking this button over here, and it brings that into the original indexing workbook so that the NGS system can use that appropriately when it's doing the indexing step. So that's it for now, and hopefully this little video was useful in basically kind of conveying this particular worksheet and how you use this. Because it is different now, we are making mixtures and premixes before we actually add them directly to the microplate. Thanks a lot, and good luck, guys.